Hello, today we're going to learn about probabilities, the basic definitions and some useful formulas. In this PowerPoint presentation I'm gonna go over the basic concepts, whereas in the rest of the videos you're gonna see how to do things in Excel. So first of all, let's start with some basic definitions. The first thing you need to know is that what a random experiment is. So a random experiment is basically a process that generates certain outcomes, right? So an example of this is the most common one is the coin toss. So we're tossing a coin, so that's the random experiment, because usually we don't know what the outcome is going to be, and of course the outcome can be either heads or tails, right? Another one is rolling a die, right? So the experiment here is the roll of a die, and the outcomes are anything of the numbers 1 through 6. Now the second thing we need to know is the event. So the event is basically it's an outcome or a collection of outcomes with respect obviously to a specific experiment, right? So let's think about the rolling a die experiment. So we have the event A being roll an odd number, right, where odd number is 1, 3 or 5, and event B being like rolling a number greater than 3. So in this case the event B occurs when the outcome of the experiment is 4, 5 or 6. So outcomes are events. So rolling 1 is an event, rolling 4 is an event, or sometimes outcomes are also called simple events. And events, usually they are reserved to denote complex or combination of outcomes. But essentially, outcomes are events as well. Now let's go ahead and take a look at some experiments and their associated outcomes. So we already talked about the first two, the tossing a coin and rolling a die, and these are their outcomes. Then from business we can have like the conduct of sales call. So we're calling somebody and the outcome is this person is going to purchase us or is not going to purchase us, right? So we have the two outcomes. Another example from finance is the experiment can be to buy a share and hold it for a year, and the outcome is that the price of the share went up, the price of the share went down, or the price of the share stayed the same. And the third and the last example here is to reduce the price of a product. So this is a pricing policy in marketing, and the outcome can be either the demand goes up. Usually what we expect to see is, when we're reducing the price of the product, the demand goes up, right? But markets are weird things, so we do not always know what's going to happen in advance. So the outcomes can be that the demand goes up, the demand goes down, or the demand does not change. So these are some ideas of what you can define as experiments and outcomes. So literally the possibilities here are infinite. Now let's talk about a few more things. So we do have what we call the sample space. So the sample space is the collection of all possible outcomes that we can get out of an experiment. And obviously that's an event too, since it's a collection of outcomes. So in the case of the rolling a die experiment, the sample space is S and is equal to 1, 2, 3, 4, 5, 6, so every possible outcome. And the tossing a coin, the sample space is heads and tails. So these two outcomes. Obviously, S, the sample space, is a collection of outcomes. We said it's already an event. And then we have what we call the probability. So the probability is a number that it tells us how likely it is for an event to occur, right? And since it's a number and it tells us how likely it is, it takes values from 0 to 1, right? So all possible numbers from 0 to 1, with 0 being that something is totally unlikely to happen, to occur, and 1 is sure that is going to occur, sure that is going to happen. So with respect to the sample space, the probability of the sample space is going to be always 1 because it has everything, all possible outcomes, so it's sure that is going to happen, so the probability of the sample space is always 1. Let's take a few more examples. Now back to the rolling the die experiment. The probability of event A, and event A was rolling an odd number, can be calculated as the fraction of the outcomes that make A to happen, to occur, over the number of outcomes that we have in the sample space. So we know that rolling an odd number, that can be numbers 1, 3, and 5, and the sample space is basically composed out of 6 events, right? So the probability of A is going to be 3 over 6 or else 0.5. And the probability of event B, that it's to roll a number greater than 3, so 4, 5, and 6, is going to be again 3 over 6 or 0.5. And as we already said, is that for every experiment the probability of the sample space is always 1. Now let's go and explore a few properties of the probabilities. So if we have like n different outcomes, right? So we have outcome 1, outcome 2, all the way to outcome n. Then we call with the probability P of O I the probability of that specific outcome, and of course, you know, the probability associated with each outcome should be between 0 and 1, which is this inequality over here, and the probability of an event will be always equal to the summation of the probability of the outcomes, right? So if we look back at the previous examples, somebody, instead of like counting 3, we could say that, you know, the probability of A is the probability of rolling 1 plus the probability of rolling 3 plus the probability of rolling 5, and probability of rolling 1 is 1 over 6, of 5 is of 3 is 1 over 6 again, and of 5 is 1 over 6, so we add them together and we get the same result. So this is an alternative way to calculate probability of events based on probability of outcomes. Now let's define a few more things. So the first thing is the complement of an event. So if we have an event A, then we define the complement of A to be another event that consists of all the outcomes that belong to the sample space, but they are not part of A. So in other words, if we have like the event A complement, which basically, remember that A is to roll an odd number, then the A complement is going to be roll an even number, because A consists of 1, 3, and 5, and the A complement is going to be 2, 4, and 6, because 2, 4, and 6, they are in the sample space, but they are not in A, so they should be in the complement of A. And the complement of B is going to be roll a number less than or equal to 3, so B equals to 1, 2, and 3. Obviously, since all the probabilities, all the probabilities, if we add them, it's going to be equal to 1. The probability of the complement is going to be 1 minus probability of A, right? So this is a very useful formula to allow us to calculate the probability of an event if we know the probability of its complement. Now, one tool that is very useful for presenting and for showing probabilities is the Venn diagram. So the Venn diagram, which you might already be familiar with, we make this square over here. So the square corresponds to the sample space, so all possible events, And then the different events can be denoted with circles, and by putting like the circles appropriately, we can get a visual representation of complements and other things that we're gonna see later on. So for the case of the complement, the white circle is event A, and the blue area is A complement. So everything that is in the sample space and is not in A, right? So that's a nice visual. Now another thing that I want to talk about is the so-called union of events. So let's say that we have two events, again A and B, and we want to find what we call the union, or in other words, we want to find the A or B, meaning that we want to find another event that consists of events that they belong to A or belong to B. First of all, we're going to consider a sets of A and B that they have no mutual outcomes, okay? And these events, we're calling them mutually exclusive, right? So we have event A that has certain outcomes, event B that has certain outcomes, and the outcomes of A and B, they're not similar, they're not the same at all, right? So in this case, as I just said, we call them mutually exclusive, and if we want to calculate the probability of event A and B when they are mutually exclusive, then we just need to add the probability of A and add the probability of B, and then the probability of A or B is going to be equal to the sum of the two probabilities, right? So that's pretty straightforward. Now let's look at the Venn diagram of this union. So this is how it's going to look like. So we have event A, event B being two circles that they have no common ground. The sample space is outside, and the union is basically just the blue space, right? So this is the union of mutually exclusive events. Now let's take a look at such an example. So we have event B being equal to roll greater than 3. We have event C being equal to roll less than 3. And first we calculate the probabilities of B and C. So probability of B is going to be greater than 3, that's equal to 4, 5, and 6. So it's going to be 3 over 6 equal to 0.5. And probability of C, it's less than 3, so that let's only 1 or 2. So the probability of C is going to be 2 over 6, and that's equal to 0.33. So the probability of the union of B and C, so probability of B or C, is going to be equal to the summation of the two probabilities, which is equal to 0.83. Now let's look at what happens and what we have when we have an A and a B that they have a common ground, right? So when we have an event A that is like this and an event B that is like this, that they have an intersection, right? So we are looking for this blue area in Venn diagram notation that is called intersection or joint probability. Joint probability because it's the intersection of the two circles, and we denote as probability of A and B because whatever is in the blue ground, it basically belongs both to A and B, right? So whatever happens here makes both event A and event B to occur. That's why we call it B, probability of A and B. Let's take a look at one such example. So we have event A being, again, rolling an odd number, which is 1, 3, and 5. Event B being roll a number greater than 3, which is 4, 5, and 6. Now event of A and B is going to be equal to the common ground, so we just need to look at A, B, and find the common elements. Here is only number 5, so A and B is going to be just the one element equal to 5, and the probability of this is going to be, of course, 1 out of 6 because it's the same with the probability of occurrence of number 5. Alright, now when we have such probabilities, we have a very useful formula that allows us to connect the OR calculation, the union, with the AND calculation, the intersection. And basically we have that formula whenever we have two events, A and B, that they're not mutually exclusive, meaning that their joint probability is not 0, and we find that the probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. Let's look at the Venn diagram, and actually Venn diagram is an excellent way to understand why this formula is. So the union in this case is the blue area. Again, the first circle is probability of A, so we add probability of A to probability of B, which is the other circle. And you might have noticed that if we just add probability of A and probability of B, we are double counting the joint probability, the intersection. So we need to subtract it once so that we balance it and have the right outcome. And that's why we have this minus probability of A and B over here. So let's do an example again. So with event A is to roll an odd number, 1, 3, and 5. Event B is to roll a number over 3, so 4, 5, and 6. So the probability of A or B is going to be equal to the summation of probability of A and B minus the probability of A and B, which equals in turn with 0.5 plus 0.5 minus 1 over 6, which is the probability of A and B that we just calculated a few slides before, and the result is 0.833. Alternatively, we can just calculate this probability by counting, because over here is pretty easy to do so. So the event A or B is going to be basically all the outcomes that belong to A and to B, just counting once, right? So we have 1, 3, 5 and 4, 5, 6. So the total thing is going to be 1, 3, 4, 5 and 6. And therefore the probability of A or B is going to be 5, because here we have 5 outcomes, divided by 6, which is the total outcomes of the sample space. And this is how we calculate probabilities by hand. In the next videos, you're gonna see how to do more complex calculations of probabilities by use of Excel and pivot tables.